Hi everyone, today I'm going to talk about how I used end-to-end modeling with deep learning. So this is my GitHub repository where I've classified three different sections for classification, regression, and image classification. So each model it follows a structured pipeline of pre-processing, architecture design, training and evaluation, performance metrics and visualization, and experiments tracking with TensorBoard. So the first thing we have is the classification model. So let me open that. So this is the classification model. So here we're just initializing the weights and biases, and I have taken the fashion MNIST dataset as the input. And then this is my model where I've defined a Keras sequential model with these layers. And then this is my optimizer that I'll be using, which is the Adam optimizer. And then this is the I'm just fitting the model and then evaluating it. After that I'll be doing the prediction, and then after that I have the computation part and also the confusion matrix, and then after that we have the classification report, ROC curve, and these are all just visualizations that I've done. So as you can see, I've accuracy we got it as 87%, which is pretty good. And then after that, this is the confusion matrix, and then this is the classification report that we have. And then yeah, if you can see, the precision and everything keeps increasing, so that is good. This is the ROC curve and this is the precision recall curve. And then this is the model architecture. So first we have the flatten layer and then the dense, then the dropout. So just the input output at every layer. And then this is what I save the model as. So these are the all layers, and then what all parameters that we have: trainable, non-trainable, all of the optimizers and etc. So this is all about the classification model that I have. And then moving forward, let's go to the regression model where I've used synthetic dataset. This is not what a linear regression dataset with noise. And then this is the model. These are the metrics that I did, and then also the TensorBoard logging. So let me go to the collab. So this is the collab for that, and then this is where I initialized the TensorBoard, and then I generated synthetic regression data taking random numbers between 1 and 10, and then I just added noise to that data, and then just splitting the data set, normalizing all of the features. And then this is a regression model where I have three different layers, same as before. This is the Adam optimizer, this is the training of the model, evaluation, making predictions, and then all of these are the metrics that I've done. So mean absolute error, mean squared error, and the r square score. So these are the this is the plot for the prediction versus true values, and then I'm logging the model architecture. So this is the training part. So if you can see, it is quite close, the prediction versus the actual fit. And this is the model architecture as I mentioned before, and this is a summary of the model. Yeah, that is all about the regression. And then even the scores are pretty good. And then the last one we have is the image classification. So this is the CFAR 10 dataset that I have, and then I use CNN model, and then the metrics are these, and then visualizations I just did a few of them. So this is the classification, image classification one, where I'm just initializing the TensorBoard thing again. This is the CFAR 10 dataset that I'm loading. Then the same thing, normalizing the data, the training, testing data, and defining the model. So these are all the different layers that I have. So here you can see the convolution of 2D and max pooling 2D are the extra layers that we have. And then same as before, we use the Adam optimizer with the metric setters accuracy, and then training the model, evaluating prediction, and then this is these are all of the um, results, I would say: confusion matrix, classification report, and also some sample predictions. I've just printed them, and then this is the model architecture that I have displayed. So this is the confusion matrix, and accuracy is 72%, which is still good. Then this is a classification report, and then as you can see, these are the predictions that are done. It's a pretty close. Dog truck prediction was deer, but I mean it still has 72% accuracy, so we can expect a little bit of mistakes here and there. This is the architecture of the model, and then we'll have the model summary. Yeah, this is a model summary. So yeah, this is all about deep learning with end-to-end modeling using deep learning. So as you can see, I have all of my results, performance, and what are the key features and how we can enhance this further. So yeah, thank you.